Problem number 35, chapter 2, page 50. So we have these two knights jousting, George and Alfred. They both start from rest. Alfred is 88 meters away from George. Okay, so the original position of Alfred is 88 meters. George is at the 0 meter position. George accelerates to the right at 0.3 meters per second squared, and Alfred accelerates to the left at negative 0.2 meters per second squared. And we're asked to find where they meet in this joust. So I'm going to start out by writing an equation involving XF, and we're going to look at Alfred first. So Alfred's final position, which is the same as George, minus Alfred's original position, which is 88 meters, is equal to 1/2 the acceleration of Alfred times the time squared. So we don't know the time, and we're looking for the final position. So we have too many unknowns. So now what I'm going to do is I'm going to take a look at George, the final position of George, which is the same as the final position of Alfred, minus the original position of George, which is 0, is equal to the original velocity of George, like Alfred's original velocity is 0. By the way, that's why I didn't put here VOA, because it's equal to 0, plus 1/2 the acceleration of George times the time squared. Now what I'm going to do is solve Alfred's equation for XF and then set it equal to George's equation, which is in terms of AG and delta t squared. So solving Alfred's equation for XF, we get XF is equal to XOA plus 1/2 the acceleration of Alfred times delta t squared. Okay, so set these two equations equal. So I have 1/2 AG delta t squared is equal to XOA plus 1/2 acceleration of Alfred times delta t squared. Okay, now what I'm going to do is solve for delta t squared. So delta t squared is equal to XOA divided by AG minus AA. So twice the original position of Alfred divided by the acceleration of George minus the acceleration of Alfred. Now, once we know time squared, we can take that and substitute it into George's equation to find XF. So XF is equal to 1/2 the acceleration of George times 2 times XOA all over AG minus AA, the acceleration of Alfred. Okay, the 2's cancel, so we have AG XOA divided by AG minus AA. Okay, so let's put the numbers in. So AG is 0.3, XO is 88, AG is 0.3, and the acceleration of Alfred is negative 0.2. Notice we have a double negative there, so that's 0.3 times 88 divided by 0.3 plus 0.2. Okay, so let's see what the final position is. and I get 52.8 meters. Okay. So the final position is 52.8 meters. What I would like to do next is take a look at the motion graphs for this problem. Position. So the position of George is a function of time. He starts from rest, so the curve starts out flat because remember the slope of a position versus time graph gives you the velocity. And he accelerates. Okay, so that's a parabolic curve. Then we have Alfred. Okay, Alfred starts at 88-meter position, and he accelerates, but in the opposite direction. So it starts out flat and does something like that. Where those two lines cross is TF. Okay, that's where they meet. That's XF. And the time is TF. Now let's take a look at the velocity versus time graphs. Okay, George, he starts out at 0 velocity and he accelerates. Alfred starts out at 0 velocity and he accelerates, but in the opposite direction that George is accelerating, and not as much of an acceleration. Okay, and here's TF. Okay, this would tell you how fast George is traveling when they meet, and this value is how fast Alfred is traveling when they meet, when they collide. Now let's take a look at the acceleration versus time graph. Okay, here's George's acceleration and Alfred's acceleration, not as much as George. And here's TF. Now, what does the area under George's graph represent? Well, that represents George's displacement, which would be equal to the final position. So if we found the area of this region here, that would be George's displacement, which is equal to XF. Right, because displacement is XF minus XO. The original position of George is 0, so the displacement is XF. So that's equal to, this is a right triangle, so it would be 1/2 the base, delta t, times the height, which would be VF, minus VO, which is 0. Okay, so that's the area under the velocity versus time curve. The area under the velocity versus time curve for Alfred also represents displacement. That would be Alfred's displacement. Okay, Alfred's displacement is equal to the final position of Alfred minus the original position of Alfred, which is 88 meters. Okay. How about acceleration? The area under an acceleration graph is the change in velocity. So if I found the area of this rectangle, that would give me the change in velocity of George, okay, which should be equal to this value that you would have at TF.